we go. Suppose I randomly select 100 seniors in Manatee County and record each one's GPA. Believe it or not, these do represent GPAs at a school. I know this is hard to believe for some of you because you would never ever have below a 4 or below a 3.5. And if you have, well, it's okay. So, we have 100 seniors. These 100 seniors make up one possible sample. This is just one sample of all the seniors in Manatee County. If we pulled another sample, that would be another sample of 100 kids, okay? So we're pulling samples of 100. All students and all seniors in Manatee County make up the population. And you guys can't see that. There we go. Okay, so we're going to talk about the sample mean because now we have to talk about sample versus population. The sample mean is X bar. So if you see an X bar, it's sample mean. And then if you see S of X, that's the sample standard deviation. The population mu, or the population mean, which is mu, and the population standard deviation is unknown. Okay. So just like what I just said to you guys, we can use X bar to estimate mu, and we can use S of X to estimate sigma. The estimates may or may not be reliable. This is why we're going to talk a lot about this today, and that's why I had you get the blue books. A number that describes the population is called a parameter. Hence, mu and sigma are both parameters. Now, you guys, you take samples of non-quantitative items, okay, or variables. So a parameter is usually represented by P. A number that is computed from a sample is called a statistic. Therefore, X bar and S of X are both statistics. And then we have a statistic is usually represented by P hat. If I had chosen a different 100 seniors, then I would have a different sample, but it would still represent the same population. A different sample almost always produces different statistics. Okay, so we have this sample, and then we're going to flip it over, and we're going to talk about these samples right here. We're going to let P hat, notice P hat is a proportion. We're going to let P hat represent the proportion of seniors in a sample of 100 seniors whose GPA is 2.0 or higher. Okay, so we have 10 samples, okay? We took 10 samples, and in our first sample, 78% of the kids in that sample, of those seniors, had a 2.0 or higher. In sample 2, 72% had a 2.0 or higher. So it's just a percentage. Do you have a 2.0 or higher, yes or no? These are the people, okay? So we have 10 samples. If I compare many different samples and the statistic is very similar in each one, then the sampling variability is low. If I compare many different samples and the statistic is very different in each one, then the sampling variability is high. The sampling model of a statistic is a model of the values of the statistic from all possible samples of the same size from the same population. So the sampling model is the statistic of values from all the different samples that we could take. In this case, depending on how many seniors we have in Manatee County, how many possible samples of 100 could we do? Okay, that's our sampling model. Suppose the sampling model consists of the samples p hat 1, p hat 2 through p hat 10. Note there are actually many more than 10 possible samples. You guys, just because there's 10 samples doesn't mean that's all the possible samples we can take. This sampling model has a mean of 0.754 and a standard deviation of 0.049, and we're going to talk about how to do that. So to find the sample mean, you guys, we just add this all up and divide it. Here's our distribution. And then here's X bar plus or minus for standard deviations. We'll talk about that. Okay, so there's two things you want. You have sampling variability and you have sampling biased. The statistic used to estimate a parameter is unbiased. You guys can't see that because, there we go. If the mean of its sampling model is equal to the true value of the parameter being estimated. So you guys, if we knew, it'd be great, right? So if our mean is the same as the parameter, the same as the population, then it's unbiased. Since the mean of the sampling model is 0.754, then p hat is an unbiased estimator of p. If the true value of p, the proportion of all seniors in Manatee County with a GPA of 2.0 or higher equals 0.754. It's unbiased estimator of the p if p is indeed 0.754. A statistic can be unbiased and still have high variability. To avoid this, we increase the size of the sample. Larger samples give smaller spread. Okay, in your textbook, in your blue book, we are going to open to page, we're in chapter 9. We're going to open to page 576. This is the page that you're looking for. So we're going to do problem 910. But before I do that, I need to go back because I wasn't recording when I did all that. So page 576, this is a really good picture of what high bias, low variability. If this is your target right here, you want to be as close to that target as possible. The more spread out your data points is, the higher variability it has. The closer you are to the target, the lower bias you have. So like this one right here is high bias, high variability because they're all spread out. That's why it's high variability. And it's far away from the target. That's why it's high bias. This is the ideal. This is what we want. This doesn't always happen. So again, page 576, you should read this. And then I want you to look at page 578, and I want you to do problem 910, bias and variability, and I want you to look at this page right here and see if we can answer it. Let's see. What do we think A is? So these are your options. Large bias, low variability, high bias, high variability, low, low, high. So, okay, so A. What do you think this is? If this is the parameter we're reaching, let's talk about variability first. So always pick one, so we'll talk variability first. What do you think? Variability is talking about how close they are together, okay? So this makes it, so what did we say, Matt? He asked me if there's medium. There's not really a medium bias or a medium variability. And I know right here you would want to put what? What does this make it look for variability? Small, but what is making it large? Yeah, all of this. So it's a large variability. What about bias? It's high bias. Because it's not as close to the target as you want to be. Okay, what's B?
Low bias, low variability.
B is low bias, low variability because everything's close. Okay, what's C?
High. I said low, high.
So what did you say? Okay, what did you say about bias? Yeah, low, probably because there's this point right here. What about variability?
High.
Variability is definitely high because they're so spread out. Okay, and D?
High bias, low variability.
High bias, low variability, because here's your target, here's where everybody is, but they're all clustered together. Okay. So now what I want you to do, and you guys, I know there's some interpretation there too. Right now, as long as you can see, especially variability, like these were all spread out. So go to page 579, and I want you to do 11 and 12 right now. So number 11 and number 12. Okay, so tomorrow we'll go over those, and then in your Flamingo book, you guys, I want you to read section 7.1, and I want you to do the check your understandings on page 425, 428, and 434. Okay?